today is space sustainability, laws of water engines, and its importance on space development. So as we and you all know that the sustainability of space development is crucial for the future of humanity. So that's why we are developing and providing the water-based propulsion system for small satellites. As you know, the water is clean and safe alternative to traditional chemical propellants. So our engines are efficient, reliable, and environmentally friendly, making them ideal for sustainable space exploration. So at Pale we understand the importance of space sustainability, and our mission is to contribute to the growth and development for the space industry through our innovative water engines. So as we said, Pale is providing a variety of water propulsion systems for small satellites. So you can see on the left side, our water engine itself, it's quite small, so it can be installed on the small sats. So our water-based propulsion system has become increasingly popular in recent years due to their low cost, high performance, and environmental friendliness. So Pale has been at the forefront of this trend, developing and producing innovative water propulsion system for small Saturn and Saturn CubeSats. Our propulsion systems have been tested and proven to be reliable, efficient, and effective. So we have worked closely with our partners to ensure that our system meets their specific customers' specific needs and requirements. So I founded this company in 2020, almost 3 years ago, with 3 other co-founders. All members are the researcher at the University of Tokyo, and we are specialists of the propulsion system. And we worked for almost 10 years. We have been working with University of Tokyo, and we have a collaboration project with JAXA to build and launch new types of satellite and satellite engine propulsion systems. So our background and my background is a kind of engineering academic side. So as we said, Pale was founded almost 3 years ago as a spin-off company from the University of Tokyo. So we have been rapidly growing, and now we have around 44 members in our team. So now we are becoming quite big companies, big chain. At Pale we have various species of equipment, including vacuum chambers, vibration machines, and summon chambers. By using these equipment, we are developing, assembling, and testing our engine's propulsion system in-house. So this allows us to ensure that our product engines meet our high standard of quality and reliability. So we are a spin-off company from the University of Tokyo. So our technology is based on a decade of research at the university. Actually, we have experiences on orbit operation of satellite engines. This chart shows our technology history before I started my company. In 2014 and 2015, we developed Xenon ion engines for microsat, and we succeeded in orbit operation. Then we started using water as propellant, and we launched our first water engines in 2019. So we keep going with the development of water propulsion system. Then last September, our thruster was launched by SLS. Also last November, and also we have a collaboration project with JAXA, Japanese Space Agency. In this collaboration project, our water ion and registered hybrid thruster, hybrid engine was launched in last year. In addition, also we already have commercial customers globally, so we have started manufacturing water engines and launched them. So recent studies have shown that the number of objects in space has increased by nearly 1.6 times over the past 7 years. This chart shows the vertical axis shows the number of objects, and the horizontal line shows the time scale, time history. So this increasing is due to the rapid advancement of space technology, such as artificial satellite, rocket, or spacecraft. However, this increase also brings about the problem of increasing collision risk in space. For this reason, those involved in space development are focusing on monitoring and managing objects in space. This graph shows the number of unique conjunction events of the time history. The number of unique conjunction events has increased by over 3.7 times since 7 years ago. This means that the risk of collision between objects in space has also significantly increased. Unique conjunction events occur when two or more objects come too close to each other in space, posing a serious threat to the safety of space assets such as satellite and spacecraft. As we continue to advance in space technology, it's important to ensure that we are taking proactive measures to manage the increased number of objects in space and mitigate the risk of conjunction events. So that's why we are focusing on the propulsion system. But I'd like to start a general explanation, especially in space. Spacecraft engines are used for nearly everything. You use them for general transport in space, like when you get into orbit or going to the moon. However, even after you get into orbit, you need to use your engine to push against gravity and stay in gravity or some as a phenomena and stay in orbit. And of course, with more satellite and space debris accumulating in orbit every year, as I mentioned before. So you need an engine to avoid collision or to conduct the orbit. And a quick primer, spacecraft engine today are powered by using all kinds of fuel or propellant, but the main one today is this synthetic liquid called hydrogen, and this noble gas called xenon. Now the problem with hydrogen is that it's incredibly dangerous. It's toxic if you breathe it in. It's burned if you get it on your skin. And so you need to wear biosuit just to handle this fuel problem. Because of all the precautions associated with this, using a hydrogen-based propulsion system is incredibly expensive. Now, xenon, on the other hand, is incredibly safe, but it's very rare. It's in the air at very small quantities, and so it takes a really long time to refine enough of this to make it available for commercial use. Because of that, it's incredibly expensive. So the engine propulsion system today is have constantly been stuck with these really expensive propellants. One which is expensive because of its dangers, and the other which is expensive because it's rare. So Pale goal, our mission, the solution is to solve this problem by powering spacecraft with ultimate green propellant, water. This chart shows the global production volume of each propellant, including water. So the best characteristic is sustainability, or how abundant or available the propellant is. For there to be a lot of activity in space, there needs to be a lot of propellant. So how much propellant do we actually have available from many of our conventional propulsion systems? it turned out not a lot. Water is really the only problem that is in sufficient abundance to easily fuel accelerating growth in the space economy. So now when we share this previously, we had someone comment out, well, the other problem don't seem to be too bad. Maybe not as abundant as water, but still pretty good. But what we are showing here is on exponential scale. So if we recut this data based on a linear scale, what you see is that water is much more affordable program compared to other programs. And then, of course, we need to look at affordability or the actual price of the program. Proportional systems provide commercial services, so cost will always be a key factor for the customers. So this is based on current day estimate, but water is by the most affordable program at $1 per kilogram, over 1,000 times cheaper than xenon. And it's already widely available in nearly all countries. So water is incredibly safe to handle, as you know. So we already consume and handle this frequently every day. So it's nearly universally abundant, accessible, and because of that, at less than $1 per kilogram. So it's the world's more affordable space. Water is the world's more affordable spacecraft propellant fuel. So that's why we are using water as propellant for our engine. So historically, water-based engines used to be heated up and turned into steam, and that steam was used to move the satellite in space. But this led to very pure fuel efficiency, or in our field, in propulsion field, it's called a specific impulse ISP. So what we did was we took the steam and then turned it into charged water plasma. We are making water plasma through a process called ECR technology, which is where we combine steam and microwave and a magnetic field to create water plasma at very low level of powers. So once you get water plasma, we can then accelerate the charged ion out of the spacecraft. And this allows us to get a significant increase in fuel efficiency or specific impulse ISP. So the performance increase is quite notable. There are only a handful of companies around the world that commercially produce water-based engine. And because their technology revolves around steam, they only using the steam technology. So their specific impulse ISP is around under the 300 seconds. So compared to other product, our water ion engine, water plasma engine, we more than triple the previous records at over 1,000 seconds of specific impulse. That is our strong point and our unique technology. So this image photograph shows our water ion and the registered hybrid thruster. So ion thruster using water plasma and the registered using steam to generate thrust. So we combine two types of water engine in one single module. So the total size is a bit bigger than 1U, 10 centimeter times 10 centimeter times 10 centimeter. And the weight mass is about 1.9 kilogram, very low weight. And the water ion engine is located at the center, and it consists of ion source and neutralizer. And also you can see the whole registered nozzle at the corners, and all components such as our water tank, control board, and the power processing unit are included inside the box. So the interface is very, very simple. Just for the user, just mounting the box or on or inside the satellite and connecting the harness and supplying the some operating voltage, like such as 28 volt or 32 volt. And this is a cool movie of our water ion thrust ion engine operation on the ground by using a vacuum chamber. And the ion engine is located on your left side. And we have an internal automatic firing sequence. At first, turn on the engine itself and start controlling the temperature and pressure. And then we ignite plasma. And finally, we accelerate the plasma like that. You can see the ion balloon to go forward the right side. So users, customers don't need to send a lot of commands to actuate inside the valve or turn on heaters or power processing units. So just sending only one or two commands to get thrust. So that's a quite simple mechanism, operation sequence for the user. So this hybrid concept combining the water plasma engine is it has a quite high ISP, and the water registered engine it doesn't have a high ISP efficiency, but it has high thrust. This hybrid concept of offering two thrusters using the same propellant, especially for the small satellite segment, is incredibly new, and it opens up all kinds of interesting maneuvers options for spacecraft operators. For instance, when you launch a satellite, operators need to consider quite a few different types of propulsion maneuvers over the course of the satellite lifetime. So typically, you want to get into orbit as quickly as possible, but this requires high thrust, which can be met with registered steam type thruster, steam type engine. But after you get into orbit, you just need tiny amount of thrust to stay in orbit, to station keeping. And here you can switch over to the ion thruster, water plasma engine, which has much higher level of specific impulse efficiency, which can help you keep your propellant volume and wet mass down. So now typically the two maneuvers categories are the big ones, but with more and more satellites getting launched and more space debris accumulating in orbit, we envision an increased use case for collision avoidance, where you may need to make sudden high thrust maneuvers to avoid collisions. And for something like this, you can momentarily switch on the registered steam thrust for the quick orbit changes before returning to the water ion thrust water plasma engines. So with our hybrid concept engines, we can offer unparalleled level of operational flexibility. However, the most exciting feature about our water-based engine technology is that it's future-proof because water is so safe and easy to handle. It fares incredibly well with so many new emerging space services. So, for example, orbital refueling is already underway, and it's tricky to handle propellant that is explosive or pressurized, but liquid water can be refueled very easily. Further out, there are companies already working on mining resources like water on the moon and on Comet. Once you can free up water that is already present in space, and you can refuel water while in orbit. So long as our spacecraft can run on water, we can continue operating in space without ever relying on Earth-based resources ever again. So by easily integrating other space services and leveraging resources already in space, our engines can drive down the cost of operating in space and truly make space activity scalable and accessible for everyone on the Earth. So finally, let me share our Pelbu's recent couple of press release activities. This is the first one. We have successfully operated our water vapor engines, water steam engine, also known as a registered thruster in low Earth orbit. So this propulsion system was installed on a nanosatellite called I, which is part of the Starsphere project led by Sony, Japanese entertainment company. They are interested in the space industry field. And we tested for the first time engine operation in space. So going forward, Pelbu aims to innovate and expand the commercial use of its water-based propulsion system for small satellites. So that means this successful test marks a significant milestone for the company and demonstrates viability of water-based engines in space. So that is our one of our commercial customers and our biggest milestone for our business side. And this is the second one, water thruster, which I led the development of as a first student leader while I was at the University of Tokyo. Is installed at JAXA and the University of Tokyo's spacecraft called Icarius, which is a nano exploration spacecraft launched by the NASA's SLS Space Launch System on last November. And it was successfully injected into its scheduled orbit towards the lunar Lagrange point. This is the world's first successful orbit maneuver beyond low Earth orbit using water as propellant. So I participated in the critical operation immediately after the launch as an operation advisor using the operation advisor. And this is the final one. So this is a collaboration project with JAXA. We and JAXA have launched a business concept co-creation project under the framework of the JAXA program to create low-power electric propulsion engines. So this co-creation activity will be pursued by leveraging the expertise JAXA has cultivated in developing and operating the Hayabusa. The Hayabusa and Hayabusa 2 asteroid exploration mission. In this spacecraft, they installed xenon ion engines, electric propulsion system. And JAXA's outlined research and development results on low pressure plants for electric propulsion system and the expertise and business know-how Pelbu has acquired in the course of developing and operating electric propulsion system. So we aim to develop and commercialize a new product, bigger engines, the 300 watt plus electric propulsion system in anticipation of an expanding market for satellite constellation and other applications by using the microwave cathode technology acquired by JAXA by developing and operating Hayabusa and Hayabusa 2. So thank you for taking the time to listen to my presentation. I hope that I was able to provide you with valuable information and insight on roles of water engines and its importance on space development. I'm always happy to continue the conversation and share my knowledge. So once again, thank you and have a great day.
Perfect, wonderful, Jun, and absolutely you provided a great insight on the water engines. And again, for the audience, I encourage them to connect with you, Jun. Also, if it's the ones that are currently watching you live or the ones that are watching these recordings, they will have a link which will enable them to request with you private networking session as well. So you're going to receive those notifications now and in the near future as well. So I've got a question for you because we got still a couple of minutes. So my question is, how do you see water engines impacting the supply chain and logistics of the space industry? And what implications does this have for businesses involved in space transportation and delivery?
Yeah, thank you for the question. So current conventional engines using xenon, it's a very rare gas. But right now, xenon is mainly produced at Russia or Ukraine. So now we cannot access to the kind of xenon program easily. So at this moment, customers actually said they don't want to use Xenon. So they would like to use other program. So for the supply chain aspect, water has a good potential to expand our business. And in space transportation aspect, so right now, some small spacecraft, small satellite does not have a propulsion system inside. So it also has a big potential for the propulsion market.